Got it. All right, so we are on YouTube right now. All right, see. Okay, great. So we are streaming live on YouTube now, so anybody who's over there will be able to catch us. But as far as Zoom goes, oh, I don't know what happened. Good afternoon, Milan. I see you in the chat saying good afternoon. I see you. I see that Paige just joined us. Welcome, Paige. We have Marie Ann joining us now. Welcome. So let us see where we were last time and just keep building. We're keeping on building forward, right? We're building on our firm foundation of the mole concept. That's what we've been doing since we started. This is our week 3. So since week 1, we've been really building that firm foundation for the mole concept, which I believe is one of the most fundamental topics in Csec chemistry. And I've said that over and over again. I keep saying it, right? I want you guys to have a firm grasp of the mole concept. And so we're going to pick up where we left off last time. Before I do that, how are you guys? I just want to check in with you. How are you doing? How are you feeling? How is school? We are about 2 months out from the exam. How are you feeling overall? Just let me know in the chat. Just drop it in the chat and be like, Miss, I'm okay. I'm like, just let me know. Okay, I want to know how you guys are. I want to know where you are and make sure that you're okay and you're in a state of mind that you'd be willing or you'd be comfortable engaging with me today, right? Okay, so I see that from Jada. All right, okay. Thank you guys for letting me know how you're doing. I see I'm doing good, tired, but okay. I'm fine. I'm good. That's what I want to hear, Nalani. Welcome. That's a new name for me. I'm not sure if you've been here all along, but welcome. And I see that Chow Vu. Let me know if I'm pronouncing that correctly. I want to know. Morrison, can you pronounce your first name for me so I make sure I'm getting that correct? Is it Chow Vu?
It's actually pronounced Savoy.
Chavoy. I love that spelling though. It's very creative. I like it.
Thank you.
So it's Chavoy. Welcome, Chavoy. Cara Gay is here. And we have Aquila is here with us. So we have a nice, solid group today. So welcome, everyone. Welcome. Oh, Elizabeth, I'm so sorry to hear that. Hopefully I'm able to help you a little bit today to kind of, get out of that state a little bit. So Aquila, for those of you who just joined in, I was just checking with the group to see how everybody is, how you're feeling, given that the exam is 2 months away, but also just in general, school, life, how are you guys? Just checking in, just doing a quick check-in to see how everyone is. So people were saying, dropping that in the chat.
I'm okay so far.
Okay, I'm happy to hear that. I'm happy to hear that. So last time, I think at the end of class, I had dropped 2 quizzes in the chat. A mole concept quiz 1 and a mole concept quiz 2. And several people have given me feedback, right? They did the quiz and I saw their feedback in real time and they've seen their feedback in real time. Some people sent me their rough work so I could see what the gaps are in their understanding and everything. And so if you haven't done it, let me just go ahead and give you them again right now. I'll give you the quiz right now again. So lest I forget. So I'm going to give you the quiz again. So you have those links and you can access that whenever at your, at your own free time. And then you can just complete those to just really reinforce your understanding and make sure that you're synthesizing everything that we're doing here. Because as I said, this is really fundamental, foundational stuff, and I don't want you to be going forward and being lost, okay? So I just dropped mole concept quiz 1, I'm gonna drop mole concept quiz 2 now. And so the goal for today, or my goal for today is really to wrap up mole concept. By the end of today, we'll be done with mole concept and start redox, oxidation, reduction, reaction. So that's kind of the plan for today. Let's see. Okay, so there are 2 quizzes that I just sent. So just check those links again for me and let me know if that works for you. And then just be doing that quiz as you go through the week or this weekend. Just set aside some time to really do these questions, because it's a vast array of questions that really test your understanding of everything that we've done so far, right? And so those are in the chat. Definitely do those, and I'll see how you did, and you'll see how you did. And then that will just give me a good metric as to where the gaps are in understanding. Like I've seen, let's see. I have seen some of the answers already, so, or how people have done. So like I'm gonna pick like maybe 1 or 2 of those and we can do them today. But as we wrap up more concept, but I'm just gonna go ahead and get started here, guys, now. So I'm gonna share my screen with you and just kind of pick up where we left off last time. Those questions that we did last time or were working on last time. I think I have about 2 more to do there. And then depending on the comfort level, I might throw in one from the quiz that I see as being a struggle area, a common area where students have been struggling in, and then we'll move on to oxidation reduction. So how does that sound? If that sounds good to you guys, give me a thumbs up, and then I'll just share my screen with you and we'll just get those questions going. How is that? All right, I see those thumbs up. Welcome, Jamar. Welcome, Jamar. It's a pleasure having you here today with us. I see that you just joined us, so welcome. Welcome, Alyssa. Welcome, Trinetta. I see Anik. I think Anik left and came back. Welcome back, Anik. Okay, so I'm gonna share my screen now with where we were last time. So last time, let me share this on, let me make this bigger. Okay, we spoke about excess reagent. I don't know if anybody wants to just like catch us all up on this again, or this whole idea as to what you're looking for. When we talk about an excess reagent, what are we generally trying to see? Can anybody unmute themselves and tell me? And then we'll just keep moving forward. But because I landed here, I wanted to just see where you guys were in your knowledge or your memory of this whole idea of an excess reagent. Can anybody tell me that? Unmute and tell me that real quick. No brave student? No? No one? Let me look in the chat to see if anybody's writing anything in the chat. I don't see anything in the chat. I don't see anything going on. I don't see anything going on in the chat. Does anybody remember what an excess reagent is and how you'd go about finding one? And I think this is one I'm like setting myself up here, because I think I might have to do this if I don't hear any answers, or I might have to at least set it up if I don't hear any answers from you. So can somebody save me from doing that, or will I have to do it? Is it that you don't understand why you're not answering, or are you just being shy or a little bit groggy? Is anybody there that would want to share with us this idea of an excess reagent, or how you would go about finding what the excess reagent is?
Miss, you would need a balanced equation.
Yeah, so you start with your balanced equation, right? And then what would you do? Because remember, first of all, and let me just say this, make this public service announcement again, the language that we speak is in moles, right? We're often given things in mass because that's how we weigh. That's the most common way of weighing things. So we'll get the weight typically, right, from a mass standpoint, but we as chemists or as budding chemists, we don't really speak in mass per se. When we're doing these large scale prep and these large scale syntheses and these calculations that require us to know how much of XYZ we need, we typically do that in a mole ratio, on a mole basis. And that's the foundation of this whole balanced equation. right? So Kalia said rightfully that, okay, we have to start with our balance equation. And from our balance equation, we'll have the ratios of this element to this element, this compound to this compound. So the balance equation gives us ratios of moles of different compounds and the proportions that they're present in with each other, right? But in this particular example, we're given mass. So what would then be our next step, Kalia? So we're given mass, we have our balance equation, but we're given mass. So how can we make what we have here in this example relatable to a balanced equation?
Miss, you would have to convert it to moles.
You'd have to convert it to moles. All right, so let me just write down the actual let me write out the actual equation real quick. And just kind of bring everybody up to scratch on this. I know we have some new people as well. Not sure if they were all able to watch the videos to catch up with us, but let's start here, because I think this was something that people had a little bit of a difficult time grasping. So let's start here and then build forward, okay? All right, so let me write in this royal blue. All right, so okay, so the equation is, the balanced equation that is 2Na, and that's a solid, right? That metal, sodium metal, and we're reacting that with sulfur, which is just S, and sulfur is also solid, right? And from that, we're gonna get Na2S, which is also then a solid, and that's a balanced equation because you see that we have two sodiums here, two sodiums here, one sulfur here, one sulfur here, right? So they're giving us this, that we have 4.6 grams of sodium, 4.60 grams of sodium, and we have 3.52 grams of sulfur, and that is to form sodium, that sodium sulfide, right? All right. So they're asking us which reactant is in excess. So from the balanced stoichiometric equation, we know what proportions we generally have to have sodium and sulfur in, right? And can anybody tell me what that proportion is based on this balanced equation? What proportion of sodium to sulfur do we need for this reaction to proceed as it is written? What proportions does our balanced equation tell us that we need?
A 2-to-1.
Exactly, that's exactly right. So we need a 2-to-1 ratio of sodium. Where's my pointer? 2-to-1 ratio of sodium to sulfur for this reaction to then proceed and give us our sodium sulfide, right? So 2-to-1, we need, if we have 20 sodium, we need 10 sulfur. If we have 10, however many, we need, it's a half, it's always half, 2-to-1, right? All right, so they're telling us that we have 4.6 grams of sodium and 3.52 grams of sulfur, but we're not working in grams, we don't speak grams, we speak moles. So what would the equivalent of that? What would the mole equivalent of each of those be? Can somebody tell me what the mole equivalent would be from a sodium standpoint? So how many moles of sodium do we have? If they tell us that we have 4.6 grams, how many moles is that?
Miss 0.2.
0.2, okay. And then how much sulfur do we have?
Miss 0.11.
Okay, so we have 0.2 here, right? And we have 0.11. All right. So from up here, guys, from up here, we're always gonna be needing half, at least half of the amount of sodium that we have for sulfur. So what Kalia just did based on the mole calculations that she did, she's told us that we have sodium, the amount of sodium that we have is 0.2 moles, and the amount of sulfur that we have is 0.11 moles. So can anybody tell me what's going on there? In theory, right, based on the balance equation, how many moles of sulfur do we need to match that of sodium? How many moles do we need? Given that we have 0.2 moles of sodium, how many moles of sulfur do we need for this to proceed as it is written?
Miss 0.1.
0.1, that's exactly right. But you see that we have 0.11 Kalia, so that is excess, right? It's a very small number, it's a very small difference, but it is still excess. It is more than that which the balance equation tells us that we need, right? Is everybody clear on that?
Oh, miss, I lost.
What was that?
I lost, miss.
Okay, all right. So tell me where exactly you're lost, and I'll clarify that.
Miss, after I get it, the ratio. Oh, miss, what you did to get those numbers below, miss?
Okay. So that's how so for that part, what we did was a conversion, right? So we're converting from mass to moles. And let me show you how we did that. Do you remember how we did that? How we did our conversion, how we go from mass to moles? So we're actually in the language that we speak, right? We're speaking moles, but they're giving us mass, and we need to convert that mass to moles. Do you remember that conversion factor, that equation, how we did that?
Yeah, miss.
Okay, how did we do that? Is that Janelle?
Yeah, miss.
Okay, how did we do that?
Miss, I think you're dividing.
Yeah, you divide your given mass by your molar mass, right?
Yeah, miss.
And so for sodium, right, the molar mass of sodium is what? So if you look at your periodic table, what's that? That mass
23.
number is that molar mass. So what's that?
23.
23, right? So when you divide 4.60 by 23, what do you get?
Zero point 0.2.
0.2. So that's exactly what we have on the left there in that same column. That would represent sodium, right? So you see here we have 2. So we pull out these stoichiometric coefficients 2 to 1, right? And Aquila, as you just said, you confirmed Kayla's answer, which is 0.2, that we got from doing 4.60 divided by 23, right? So that's how we got that number. We're converting our mass to moles. So we did 4.60 grams divided by 23 grams per mole. And that told us that we have 0.2 moles of sodium. Right? Janelle, is that clear to you now? How we got those numbers down at the bottom?
Miss, for sulfur divided by the same 4.60.
No, so for sulfur, no, they're telling us that we have 3.52 grams of sulfur, right? From that question, they say we have 3.52 grams of sulfur. And if you look at your periodic table, the mass number of sulfur then is what? What's that mass number? Which is essentially what our molar mass is, right? So what's the molar mass of sulfur then? From your periodic table.
$28.
20, I don't think so.
32.
What is it?
32.
32, that's exactly right. So we're gonna divide that by 32 now, right? Did you find that, Janelle? Did you see that? That is 32 grams per mole.
Yeah, miss.
Ooh, why did I do that? 32 grams per mole. Okay, so we're dividing then that 3.52 by that 32 grams per mole, right? Because that's now our molar mass. So it's our given mass divided by our molar mass, right? And that molar mass we just said is 32. So then what does this number work out to when you divide that?
0.11.
Exactly. So that's what we had there. And so that's where we got that from. So is that clear to everyone now? Are we all on the same page now? Is that clear, Janelle?
Yes, miss.
Okay, so that's where we got these two numbers from, right? And so now what we're saying now here is that the ratio, the proportion in which we need sodium to sulfur for this reaction to proceed as it is written is a 2-to-1 ratio. So if we have, based on our calculation, we have 0.2 moles of sodium, at the minimum, at the very least, we would need 0.1 mole of sulfur. But you can see here that we actually have more than that, right? We have 0.01 more than we actually need, right? Similarly, if we are saying, okay, we have 0.11 mole of sulfur, right? We have 0.11 mole of sulfur. It's a 2-to-1 ratio with sodium. How much sodium would we need for this to proceed as it is written? Think of that. So let me ask that again. The mole ratio is 2-to-1. That's not changing, right? So now let's look at it from the perspective of the sulfur. We have 0.11 moles of sulfur. How many moles of sodium would we need for this reaction to proceed as it is written? Like at a basic level, at a minimum, how much sodium would we need to match this sulfur?
Miss 0.22.
Exactly, but we don't have that, right? We have only 0.22, right? We only have 0.2. We only have 0.2. Is that what I said? We only have 0.2, right? So that means that what's in excess then is our sulfur. Does that make sense?
Yes, miss.
Yes, miss.
Yes, miss.
Okay, because it would be the sodium that's limiting, right? Because in theory, we need 0.22 of you, but we only have 0.2, right? So that's limiting and our sulfur is excess. Do we all understand this concept of an excess reagent now? And then by the same token, a limiting reagent, do we understand this now? Everyone, let me see those thumbs up or those yes misses. You can say whatever, just let me know. So I know that we're all on the same page, okay? All right, I see those thumbs up and I heard those yeses and I see stuff going on in the chat. Let me see what they're saying. Let me see. I'm gonna clear this screen, okay? Do you guys, I have a question for you guys. Do you take notes during these sessions or do you just listen? And what's your process? Can somebody tell me? Like, what's your
Miss,
process?
I take notes.
I take notes, miss.
Okay, just checking. There's no right or wrong answer. I just want to know how you guys are processing this material. There's no right or wrong. It's what works for you, right? I generally would recommend taking notes though, because I think it kind of helps you to focus a little bit more, on what's going on. And you can put down your key points there and so on and so forth. But I mean, you know yourself best, right? And how you work best. But I wanted to just check in to see how you guys were processing everything here. All right, so let's move forward. So we did that, what was that? Excess reagent, all right. So then here is something along the same line. Well, let me stick up in here and I'll go ahead to do an Avogadro's law calculation. We did this one last time. Were you all comfortable with this idea or this calculation to find a volume of 3.08 grams of carbon dioxide? Let me see, at what condition did they say? At SCP? Were we all good on this? Because we're gonna build on this. I'm gonna give you a more, increase the complexity just a little bit, actually not that much. And then we go back to that question that I showed earlier, which is more comprehensive. So how are we on this? Let's see.
Miss, someone in the chat is asking you to work it again.
Go through it again. Okay. Okay, so let me answer Paige's question too before I delve into this. So Paige was asking me what things I need to know before starting the topic. Moles. So like moles is like, I'm realizing that because of Corona, the teachers aren't necessarily going in that order because it's tough times. But according to the syllabus, which is what I follow, right? The mole concept, and I think I showed this slide last time. Let me stop sharing this. So So the mole concept is like, and the way I have them numbered to guys is exactly how it's like numbered in the syllabus. So like, cause I'm going line by line by the syllabus, right? So let me pull that up. So let me just do this real quick for Paige to show her what we're building on really. So you have states of matter, that's your first topic, right? So that's your solid, liquids, gases. They're telling you about, you know, the different particles that you have, which are basically atoms, ions, molecules. You have mixtures and separation. So how do you separate these mixtures and compounds and all these different things that you have? How do you separate them? Atomic structure. No, atomic structure is important. You have to know about atomic structure before you then go into mole concept, right? Because this idea of protons, electrons, and then, you know, really what constitutes an atom is important for you to know. And so ions and ionic structures and so on is important for you to know if you're going to do moles, right? Periodic table. You see, I'm referring to the periodic table a lot. I'm asking students to refer to the periodic table to get that mass number, which is then your molar mass. So you need to know about the periodic table, periodic trends, and all these different things. And then structure and bonding. So I had a question in the quiz that was largely based on structure and bonding, but then you're adding the complexity of a relative formula mass, and you're supposed to use that to figure out what the actual relative formula mass is, right? So these all tie nicely together, and then you get to the mole concept. So that's where we are, Paige. So does that answer your question? Does that help a little bit? You're asking me what you need to have learned or known before starting this topic. Is that okay for you? Have you learned those things in your school? Let's see, I'm pulling up my slides now, guys. That's what I'm doing. Where we stopped. Okay, so we stopped here. Mole calculations using Avogadro's law. But I haven't heard back from Paige. Paige, are you there? Is that okay? Okay, she says yes. Great. All right. Okay, so Elizabeth, somebody was saying that I should go through this again. Okay, so again, we speak moles. Moles is our language, right? That's what we speak. But here we're given a mass of carbon dioxide. So that's a mass of a gas. And typically, guys, when we think of a gas, and you're measuring a gas, you're typically given a volume, or you typically want to, from an everyday perspective, right? You typically think of a volume of a gas, or a volume, how much volume does this gas take up, right? That's how we typically think of it. So they're asking you now, okay, we have a mass of carbon dioxide. That's 3.08 grams of carbon dioxide, and this is at STP, so that's standard temperature and pressure. Does anybody remember what those conditions are, and what does that whole thing mean that you're at STP? Just shout out and let me know, or write in the chat, so that we know that everybody in this class knows what STP is. So let me know before we move forward with this question.
Miss, at STP, 1 mole of gas occupies a volume of 22.4 dm cubed.
Okay, so that's great. And what's STP? What's the temperature, and what's the pressure that's associated with that?
Miss, the temperature is 0 degrees Celsius, and the pressure is 760 millimeters of mercury.
That's exactly right. So let me just jot that down here real quick for everyone, so we're all on the same page. All right. So STP is standard temperature and pressure, right? The temperature is 0 degrees C. The pressure is 760 millimeters of mercury. Right, that's how we talk about pressure at the CXC level. It's in terms of millimeters of mercury. All right. So, and then also 1 mole of gas occupies 22.4 decimeter cube. And what's the equivalent of this in centimeter cube, guys? What's 22.4 dm cubed in cm cubed? Anybody?
Miss 22,400
Exactly.
cm cube.
Exactly. So I'm gonna write that down there too, so we see that number and see that it's really a conversion factor. It's you multiply by 1,000, right? That's how you get from dm cube to cm cube. So guys, remember that if you're writing down something, write that down. To go from dm cube to cm cube, you multiply by 1,000. Because we have a question after this that's gonna require you to know that. Right? So multiply the dm cube by 1,000, you get cm cube. If you get cm cube and you want to go back to dm cube, you have to divide by 1,000. So write that down, paste that over your bed so you remember that conversion factor because it's very important. All right. All right. So now we're saying, okay, we know what STP is. So we're all on the same page with that. We know the volume occupied by a mole of a gas at STP, and that's 22.4 decimeter cubed or 22,400 centimeter cubed. All right. So now we know, now go back to the question now. We have 3.08 grams of carbon dioxide, that's CO2, right? We want to convert that to a mole, right? Because that's how we're going to be able to go from, to get a volume, right? Because we know how much a mole takes up. A mole takes up 22.4 decimeter cube, but we don't yet know how many moles of carbon dioxide we have. We know a mass, but we need to find a number of moles first, and then we can say how much volume we have, right? Do you guys kind of follow that train of thinking? That's how you think about these things. That's one way of thinking about these things, right? So, all right, we know 1 mole takes up 22.4 decimeter cubed. How many moles do we have here? How many moles of carbon dioxide do we have here? And how will you go about finding that? Go ahead.
0.07.
0.07. How did you get that? Let me see who is talking. Who is it that's talking?
Miss Robertson.
Robertson. Okay, so how did you get that number, Robertson?
Miss, I found the molar mass for the carbon dioxide, miss. And then
What's that? What number is that?
Give me a minute.
44, right?
Yes, miss.
Okay, so you got that, and then tell me what you did next.
I divided 3.08 grams by 44 anagram.
Okay, that's exactly right. So let me just write that down and have that here. Let me write that down. Robertson gave us that. So let me write that down. This is not coming up. I don't know why my pencil is hiding. Okay, I think it's bad now. I think so. Okay. So you said 3.08 grams divided by 44 grams per mole, because that's the molar mass of carbon dioxide. And from that, what was your number again? How many moles do we have?
0.07.
0.07 moles of CO2. All right. All right. So now I'm going to write it. Let me see where my pencil is. I'm going to write it here. So 1 mole, we said, takes up 22.4 dm cubed, right? So 0.0, what did I write? 0.07? Is it a 7 that I wrote? 0.07.
Well, that look like 1.
Yeah, it does look like 1. It's 7, guys, okay? It's 7. 0.07 mole then occupies how many dm cubes? So that's that x that we're finding, right? So we can just cross multiply and say boom, bam, right? So what's that now? Tell me that in the MQ. What's that answer? Because then that's our answer. What's that answer?
1.6 dm cubed.
1.6?
Yes, miss.
1.6 dm cubed. All right. So are we all clear on this calculation? If there are any questions, now is the time to
Miss,
speak.
you could go over that part for me, please.
Which part? The last part?
Yes, miss, where convert it to volume. When you find calculate the volume.
Oh, okay. So the last part where I get to the volume.
Yeah, miss.
Okay. All right. Let me see if I can write that out a little bit better. Or in more detail. Let's see. So 1 mole, we said at STP, 1 mole of a gas takes up 22.4 decimeter cubed, right? So if we only have 0.07 moles, that means that we're going to take up much, much less than that 22.4 dm cubed, right? So then we can use ratios to find out what the volume would be if we only have 0.07, right? So that's essentially kind of what I did there. In the corner, I was saying that, let me clear this so I can write it. So you can see, I was basically just saying that, okay, 1 mole is to 22.4. So 0.0 mole is to X. X is our unknown. So I did a cross multiply. Oh, the 44 came from the molar mass calculation of carbon dioxide. So the mass number of carbon is 12 and the mass number of oxygen is 16, right? And we have 2 oxygens. So 16 times 2 is 32. And that 32 plus that 12 gives us 44, right? So that's our molar mass of the compound that is carbon dioxide. So that's 44 grams per mole. And then we just divide our given mass by that 44 grams per mole and we get our moles. So now we get that we have 0.07 moles of carbon dioxide, right? Is that clear, Paige? All right, let me keep moving to this now. All right, let me see if I can write it out. Make it spell it out a little bit clearer how I did, because I kind of just like said you'd cross multiply, but maybe that's not immediately obvious to everyone, and that's okay. So let me just do that now. So 1 mole is to 22.4 dm cubed. So 0.07 moles is to X, right? And so if I cross multiply, what I'm gonna then get is I'm gonna say X times I'm gonna say X times 1 mole is equal to 22.4 dm cubed times 0.07 mole. And so guys, the reason why I always say you have to pay attention to units is exactly this, right? So you know from math that when you're trying to make X the subject of this equation, right? So you would then say X is equal to 22.4 dm cubed times 0.07 moles divided by that 1 mole, right? I divide by that 1 mole, and because I did that now, my units cancel out, and my whatever I get here for X is gonna be in dm cubed. Do you guys see that? That's why your units are important. So multiply the 22.4 times 0.07, you get 1.6. Is that clear to you guys? Does this all make sense that I wrote it out now? You can see it, how it actually looks?
Yes, miss.
Okay.
Yes, it have to be, you have to roll it up to 1 decimal place. What if I write 157?
Yeah, you can write 157. Honestly, I would recommend you keeping as many sig figs as possible. Obviously, don't write no long nothing, right? But like I think I have to double check what CXC says, but I would imagine that at least 3 sig figs is okay, because think of the problem that we did just now when we were talking about excess reagents, right? You see, if you had just written 0.1, you wouldn't have known. Do you see what I'm saying, Aquila?
Yes, miss.
So I would say at least keep, so that would be what, 2 decimal places, right? That was, so that's 3 sig figs. Yeah, but I would recommend you keeping at least 2 decimal places, because then you'll see if there's anything interesting, let me say that, happening, as it was the case for the previous example where we did excess reagents, okay? So I would say that, but I have to double check what CXC says is how many you should use. Actually, I think I saw that this morning. Let me check. Okay, so here's what it says. In chemical calculations, it's important to give the answer to the correct number of sig figs that fits the data given. So depending on the data that you're given, you should know how much you should keep, right? Don't keep too much, that more than what the question would imply that you should keep, and don't keep less. Because if you keep less, you're gonna miss interesting trends, as I said would have been the case for the limiting reagent, excess reagent situation. Okay, guys? So that's what they're saying. And they're telling you about sig figs. They're saying the answer given should be the same as the least number of significant figures in the data. So that's just kind of a rule of thumb. You can kind of revisit that a little bit more on your own. If you want me to, I can delve a little bit deeper into it next time, this whole idea of sig figs. But they're saying that use the question to kind of guide you as to how many sig figs you should have. So, okay, for this particular question, right, the only number that we're given is the mass of carbon dioxide, and that's 3.08 grams. And so I would then say, keep 3 sig figs, because this is 3 significant figures, right? 2 decimal places. So keep that in your answer. So if we did that, what would our answer be here? Well, first of all, what would our moles have been? Is that still okay? Are we still okay as far as our moles go?
Yes, miss.
Okay, so then in terms of the volume, what would our volume then be if we're keeping 3 sig figs?
1.57.
1.57. Okay, so let's do that. Let's do that going forward. Let's not round prematurely, because you might miss interesting trends. Okay, how is that? That's what I would say. All right. Okay, so let's move on to the next question, which is building on Avogadro's law, and extra points for anybody who realizes. We might have somebody here who already knows, but extra point if anybody realizes that there's like a massive shortcut in this question that we're gonna do next. Okay, it's Avogadro's law question, but let's see. Let me just clear this screen so I can move on. Let me clear this screen. Where's my thing? I don't know why this struggle is so real right now. All right, let's see. Give me a minute, guys. My pencil is always like, not where it should be. All right, let's see. I don't know why it's doing this. This is so annoying. Let me see where it is. Clear. At least I can clear my drawings. I did that. Okay, let me find back my mouse. And then move to the next thing. Okay, no, not yet. Let me get my mouse. Oh my God, here it is. I got my mouse, guys. All right. Okay. All right. So here's our next question now. We're gonna do this, and then in the interest of time, all right, let's do this, and then I'll see where you guys are after this, and then we'll move forward. Because as I said, let me not waste time saying this, but like, I am here for you guys, and I want you to fully grasp more concept before I move on to a new topic, right? So let's do this and see where we are in our minds, in our thinking, and then we can move forward, okay? All right. So who wants to just kind of outline the steps that you would take for this question for me? So let me see how you guys are thinking about these problems. Let me not talk. Let me let somebody else talk and share how they would approach this question. You're already given the balanced equation here for the conditions for which hydrogen reacts with oxygen, right? We're given our balanced equation and they're asking us to find a volume of oxygen that would be required to produce 960 centimeter cubes of steam when it reacts with excess hydrogen, and it's at RTP. So is there anybody who wants to just kind of walk me through a general approach to this question? Just unmute yourself and talk to me. Anybody? Is anybody there? Oh no. Let me take this off. What's this? Okay. All right, Aquila, you're highlighted. Do you want to speak to me?
No.
No? Okay. All right, so let's see here. All right, there are multiple, well, at least two approaches that you can take to this question, okay?
Miss,
All
can I
right.
try?
Yeah, go ahead. And talk us through what you're doing. Pretend that you're me and talk and teach and let me hear how you
Miss,
would
I
do
don't think I can teach though, but
it. Okay. Well, talk,
Miss,
at least talk us through how you're approaching or how you're thinking about it.
Miss would use the balance equation to determine the mole ratio, so it would be a 2 to 1.
2 to 1 of what to what?
Miss, of steam to oxygen. It's asking for the volume of oxygen.
It's a
So
2
Miss,
to 1 of steam to oxygen. Okay, got that. All right.
yes, Miss.
So because
Miss,
they told us that we have excess hydrogen, so you're not worried about hydrogen, right?
No, Miss.
Okay, so then go ahead. Do you want to write it? Do you want to write on the screen real quick? Like just write out your thought process. Or if you don't want to write it and you have a text box, maybe you could type it out real quick so that we all see. Yeah, go ahead and do that. Because I know that we have a lot of visual learners here. Yeah. So you can, are you comfortable doing that, Kalia? Okay, so you said 2 to 1. So write down what that 2 to 1 represents. 2 to 1 ratio of, so here's a 2 to 1 ratio of steam to oxygen, right? And then just build on that so that we see. And if there are any questions at any point from anybody, definitely let me know and stop us. Stop me, stop Kalia, and just ask, right? If it's not clear, and then we can clarify as is needed. But I want a student to from their vantage point, from where they're sitting, how are they seeing this, right? So Britannia is asking a question about the ratio. So the ratios, Britannia, is essentially just you pulling out that number that is before the compound or the element, right? So you see for hydrogen, it's 2, so it would be a 2 here. For oxygen, is 1, so it would be 1. For steam, it's 2, so that's where that 2 comes from. So actually, Kalia, if it's not too much for you, can you flip this and just show that we're going from product to show that we're going from reactant to product. So just right so that everybody can see more clearly, you could say 1 to 2, right? Instead of 2 to 1. Because you're saying the ratio of product to reactant, but let's do the ratio of reactant to product. Does that make sense what I'm asking?
Yes,
Okay, I mean, what you have still works, but it's because I was trying to explain the ratio to Britannia, why I was saying if you did 1 to 1, it probably would be easier to see, but that's okay. It's okay, I can explain it how you did it here. So Britannia, does that make sense now? Do you see where we got the ratios from? It's like just the coefficients here, or the numbers that are before the compound / elements. Is that clear, Britannia? Let me know. I can't see your thumb if you're giving me a thumbs up. So just write in the chat, say yes, miss, no, miss, so I know, and then we can keep moving on with the explanation. Okay, she said yes, miss. Is everybody else clear on that? Just give me a thumbs up, and then I'll show you the rest of the
Miss, I asked the ratio, miss.
What was that, Janelle?
Miss, you're asking if we clear on the ratio.
Yeah, where the ratios come from. Yeah. Like the ratio of reactant to product versus product to reactant, like versus product versus reactant to reactant, because sometimes you have to figure that out too, right? And so what we're saying is that the ratios are just the stoichiometric coefficients of what we have in the equation as it's written. It's just a coefficient. It's just a number that's before the element.
Miss, why it says 1 to 2, miss?
So here, because okay, let me underline this for you guys so you can see what or elements or compounds of interest are, right? So because the question is asking us about what volume of oxygen would be required to produce 906 centimeter cubes of steam, we know that and it tells us that hydrogen is in excess, so we're not worried about that. We're not going to be limited by that, right? So we're not thinking about hydrogen in this question per se. We're thinking of oxygen and steam, right? So when you look at the stoichiometric equation or the balanced equation, you see that oxygen and steam exist in a 1 to 2 mole ratio, right? So for every mole of oxygen, you're gonna get 2 moles of steam, right? For every mole of oxygen, you're gonna get 2 moles of steam. And by Avogadro's law, which I mentioned this or in our first lecture, by Avogadro's law, it says that equal volumes of gases under the same conditions of temperature and pressure, because they're both volumes being measured at RTP, so they're at the same condition of temperature and pressure, right? Equal volumes would take up the same amount of, equal volumes will contain the same amount of particles, right? If they're measured at the same temperature and pressure. So essentially what that is saying is that let's not worry too much about what makes up a gas. So let's not worry about whether it's oxygen, whether it's steam, whether it's hydrogen. As long as it's a gas, equal volumes will contain the same number of moles, right? So that's the statement of Avogadro's law. I could go back to it on the screen, but I don't want to get rid of what we have. But because based on what we know about that, right, that Avogadro's law, we can see a very quick shortcut here, which is what everybody used essentially, is to say that because of Avogadro's law, and we're working with just gases here. There are no solids, there are no liquids, they're all gases, right? So they're all equivalent pretty much. So if literally all we're looking at now, this is just a ratio problem. Because of Avogadro's law, we can simplify this to a ratio problem, because of the whole idea of equal volumes of gases, or every single gas containing the same number of molecules, you know, at room temperature and pressure, or whatever the temperature and pressure is, as long as they're all at the same conditions, they're gonna occupy the same amount of, they're gonna have the same amount of molecules or same amount of particles in them. So we can reduce this problem to a ratio problem, which is exactly what Kayla wrote here, and I see Paige did the same thing in the chat, right? But essentially, so it's 1 to 2, it's 1 to 2 of hydrogen. Well, it's a 1 to 2 ratio of, so Brittany is saying she thought it would be a 1 to 2 ratio of hydrogen to oxygen, but so it would be a 2 to 1 in that case, right? The ratio of hydrogen to oxygen would be 2 to 1. The ratio of oxygen to hydrogen would be 1 to 2. So you are right in that respect, but we're not concerned about hydrogen right now because it's in excess, right? So we can just rule out hydrogen for now. It won't hinder us. We don't really care about hydrogen now. All we care about is oxygen and steam. And oxygen and steam are in a 1:2 mole ratio, right? So they're saying, okay, we know from the balance equation that oxygen and steam are in a 1:2 ratio. If I have, based on Avogadro's law, that's what we're thinking of here now. If I have 960 centimeter cube of steam, what volume of oxygen would I have needed to get there, right? And because it's Avogadro's law, literally, we can just divide that volume by 2 because it's a 1:2 ratio, right? So if I have 960 centimeter cubed of steam, that means that I must have started with 480 centimeter cubed of oxygen because it's a 1:2 ratio. Is that clear to you guys? Let me know in the chat. Use your emoji so I know if this is connecting or if it's missing. Let me know, right? Because all we're doing now is just ratios because of Avogadro's law and because it's a gaseous equation. It's a gas state equation. They're all gases. They're all at RTP. So literally all we're doing now is a ratio. So the steam in the equation is the H2O. So steam is just H2O as a gas. It's just water in the gaseous state, right? So it's H2O gas. So that's on the right-hand side of the equation. That's our product. Let me show you. It's here. It's that 2H2OG. That's our steam as far as this equation goes, right? Do you see that, Britannia? So that's where the steam is. And we have oxygen being a 1:2 ratio with it. So if we have 960 centimeter cube of steam, then we have 408 centimeter cube of oxygen. If that's clear, give me a thumbs up. If it's not, let me know. There's also an alternate way of doing this, a longer way of doing it. Janelle, are you saying something? Who's saying something? Talk to me.
It's Savoy. Miss, with the way that it is shown in the chemistry concise book in for the second example on the mole and volume of gases. Could you please explain it in that method?
In that way?
Yes,
So what
miss.
was that way? Was that way using
It's
mole?
like using what?
Was it like a conversion to moles using the 24 dm cube?
Yes, miss.
Okay, I can do that. So that's a more rigorous way, and you should definitely be able to do it that way. But this way that these students are doing it is a shortcut way, which is also equally good, right? And will save you a lot of time in an exam if you can catch this trick, right? But let me do it the more rigorous way, as Shavoy is saying. Is that okay with you guys? Where are you on this? Let me see. Give me a minute here. All right, so does anybody want to get us started on that? Just kind of talk us through what that alternate approach would be. Anyone? How would you then do this from the standpoint of finding the moles that you have? So going from volume to moles and then do a kind of like a molar volume kind of calculation approach. Does anybody know how we would get started there? I'm gonna do it, I'm gonna write it up, but I want somebody to get us started. I'm gonna write it so that we all can see it and we all have an understanding of it. But I wanted to hear if there's anybody in the chat who would just kind of just walk us through what they would think or how they would approach that from the other standpoint, right? Anybody?
Just to find the number of moles of oxygen is.
Yeah, you'd find number of moles of oxygen to then get to the volume, but you have to start with finding the number of moles of what you know you have, which is steam, right? So your first step would be to find the number of moles of steam that's present in that 960 centimeter cube. Do you see that, Janelle? So Nalani says, okay, so Jamar says, find the molar mass of oxygen and steam first. Okay, so those are, what are those? Jamar. And then Nalani says, find the moles in 960 centimeter cube, then use the molar ratio to find the moles of O2. That's exactly right. So Jamar, do you mind shouting out the molar masses for us for steam and oxygen? Okay, so let's see. So he says oxygen is 16 grams per mole. But we have O2, right? So that's a diatomic gas now. So what's that? 32, you said. Okay, so you multiply that 16 by 2. So 32 for oxygen. So that's 32 grams per mole for oxygen. And then what would it be for steam? Steam is just water. So that's 18 grams per mole, right? So that's 2 times 1, 2 plus 16, 18. All right. But first now we need to find the amount of moles of steam that we have. So how do you go from that volume of 960 centimeter cubed? How do you go from that to moles, right? And the hint is in the RTP, right? So we know that 1 mole of gas at RTP occupies 24 decimeter cubed, right? So if, and that's why I said the conversion is important, right? 1 mole of gas at RTP occupies 24 decimeter cubed, but they're giving us the number in centimeter cubed. So it's easier for you to go one way or the other. It's either you convert the 960 centimeter cube to decimeter cube, or you just convert, or you just use what the volume is at RTP in centimeter cube. So that would be 24,000 centimeter cube, right? Let me write that down for you guys so you can see. But are we all clear on that? If not, say something in the chat. And if it is, also say something. So I know. But basically, because they give us the volume in centimeter cube, and we know what RTP, the volume for 1 mole of gas at RTP is that 24 dm cube, we can convert that dm cube. Let's convert that dm cube to centimeter cube. So we'd multiply 24 by 1,000, and that would be 24,000. And so we doing our ratio thing that I showed you guys just this past slide, you'd be able to find the number of moles of steam. Can somebody tell me what that is real quick? The number of moles of steam that we have based on the fact that we know that 1 mole takes up 24,000 cm cubed at RTP. And we have a gas that's taking up 960 cm cube. So that's for sure less than a mole, right? So Nalani says it's 0.04 moles, right? Akeen, I hope I'm pronouncing your name right. Akeen also corroborates that, says it's 0.04 moles. All right. So that seems to be the number. More than one of you are saying it. All right. Are we all clear on that? Is everybody clear on that 0.04 moles and how we got
get 0.04.
What was that?
How would I get 0.04 moles?
Okay, I'm trying to write it on my screen, but the struggle is real. Can one of you guys access my screen and write it? How you calculated it? Nalani, Akeen, Deschanel says it's 960. Divided by 24,000, right? Do you follow that, Janelle? Like you're dividing the 960 cm cube by 24,000 because of what I showed you previously with the ratio, where we're saying, okay, 1 mole of gas takes up 24,000 centimeter cube. X mole of gas takes up 960 centimeter cube. So when you do your cross multiplication, that nice fancy stuff, what you're gonna get is 960 centimeter cubed divided by 24,000 centimeter cubed, which is 0.04 moles of steam, right? All right, so then now, from then, what's our next step? From then, we have to apply our mole ratios, right? So if we have 0.04 moles of steam, and we know that the ratio of oxygen to steam is 1 to 2, so whatever we have as far as steam goes is twice as much as we started with for oxygen. Let me repeat that. If I have 0.04, if I am steam, and I am 0.04 moles, and I am twice as much oxygen, then that means that I have to half me to get oxygen. So if I half me, I'm gonna be 0.02 moles oxygen, because it's half, it's a 2 to 1. So I'm twice as much as oxygen as there is oxygen. So if there's 0.04 moles of me, they're going to be 0.02 moles of oxygen. Are we clear on that? So now we're at moles. We have one more step. 0.02 moles of oxygen is what we have. Is that clear?
Yes, miss.
Okay.
Yes.
Okay, I see those yeses. All right. So 0.02 moles of oxygen is what we have, right? Now going back to this idea that we're at RTP. We are at RTP, so that means that 1 mole of gas takes up 24,000 centimeter cube. I am oxygen, and I am only 0.02 moles, right? So I'm 0.02 moles, 1 mole takes up 24,000 cm cubed. If I am 0.02 moles, how much space am I gonna take up? And again, you do your cross multiplication. 1 mole is to 24,000 cm cubed. 0.02 moles is to X centimeter cube. So when you do your cross multiplication, what you're gonna end up doing is multiplying 0.02 times 24,000. And what is that number, somebody? Let me know. What is 0.02 times 24,000? And please forgive me for not actually writing this out, but my screen is like kind of frozen at the moment. So sorry. Hopefully you've been able to follow my hand and my voice and what's going on in the chat. But is that clear to you guys? I hope this is making sense and that you're seeing that really once you have an understanding as to what's going on from a balanced equation standpoint, you literally just ratios, right? All you're doing is just messing around with these ratios, but you have to know the right ratio to use, because if you don't know the right ratio and where you find that, and you don't know these little rules, right? Like this 24 dm cube for RTP and this 22.4 for Csec. If you don't know this stuff, it's gonna be hard for you to then move forward, right? So that's why I'm spending my time on this. I am okay with spending my time on this, and I hope it's okay for you guys. But I think it's important to really grasp the fundamentals of this stuff before rushing ahead, because you'll see that the other stuff will be very easy for you once we have this down. And I know that, and that's why I'm taking my sweet time with you guys on this. Because I know that if you grasp this properly, you'll be good. So let's see now. My mouse is back. Hallelujah. Everybody's saying 480 cm cubed. Boom, bam, bam. Everybody get that? All right. Is that clear though? Is it clear? Is the explanation clear? Does it make sense? If it does, give me a thumbs up so I can see what's going on. So give me those thumbs up. Give me those thumbs down too. Thumbs downs are okay. Thumb downs Those are okay, right? But I just want to know where you guys are. I see a couple thumbs up. Not as many as I would like. Not as many as I would like. So if you have a question why you're not putting your thumbs up, or maybe you took a little nap in halfway, I don't know. But whatever the case may be, let me know, okay? So keep those thumbs up. Keep those thumbs up so I can see. I'm looking at everybody now. So put back your thumbs up so I can see what fraction of you are just like getting it, not getting it, or maybe sleeping. So let me know. Put back those thumbs up so I can see. Let me see. I'm looking now. I'm looking at everybody. I see that there are quite a few of you guys who are not saying anything at all. No thumbs down, no thumbs up. But there are also a lot of you who are saying thumbs up. So that's encouraging. That's promising at the very least. Why do I keep going to this oxidation reduction stuff? We are not there yet. All right.
Miss, I have a question. Just to drift back a little.
Okay, let's see who that is. Karage. Okay, Karage, welcome.
Read the 1 moles of gas. Is 24,000 dm cube the standard measurement?
That's the room temperature measurement. Yeah. So RTP. So at room temperature and pressure, it would be 24,000. And then you remember for the other one that we just did, I said for STP, it's summarized again. So RTP. So at room temperature and pressure, if they give you that, like they did here, it would be 1 mole of gas would take up 24 dm cubed or 24,000 cm cubed, right? And then at STP, so this is a standard, is what I would say. I don't want to use the word standard because standard would imply this in this case. But that's like a given. Let's just say it's a given, right? It's a given that if you're at RTP, 1 mole will be 24 dm cubed, which is the same as 24,000 cm cubed. 1 mole of gas. Let me clarify that. 1 mole of gas would take up that amount of volume. And if you're at STP, which is now standard temperature and pressure, 1 mole of gas would take up 22.4 dm cubed, which is the same as multiply that by 1,000, 22,400 cm cubed. So remember this stuff. Stick this in a post-it note on your mirror, in your bathroom, in your bedroom, over your bed. Anywhere you need to put this, you put this somewhere so that you remember this. Or if you write it in your book, write it and box it up. Like how I'm boxing it up right now. Box this up. Because like when it comes to molar volumes and Avogadro's law and like any of that, anything involving volume and gases, you have to know this. Like you have to know this stuff. Like if I didn't know this stuff, I couldn't have started this problem, period. Like even the shortcut that we did before, it required you knowing Avogadro's law at some level, right? And knowing that what the volumes are and that they will be equal. Volumes would take up the same amount of space. Like you have to be comfortable with this whole idea, this Avogadro's law and what that means from a numerical standpoint in terms of volume taken up in each respective case. So how is that, Karagi? Does that help?
Yes, I'm clear now, Miss. Thanks.
Okay, very good. That's what we like to hear. All right, so are there any more questions on this? Are there any more questions on this?
No, Miss.
Okay. All right, so I'm gonna clear this then, clear the screen. And then now I'm gonna give you one big problem. Oh my gosh, we have 15 minutes left. All right, guys, we're taking our time and that's okay. I don't know if we're gonna start more concept today, but not more concept, what am I saying? We're not gonna start oxidation and reduction reactions today, but I think that we are building indeed a firm foundation. And once I hit that topic, it would be like, we can finish that in half an hour. So let's not worry about not starting oxidation and reduction today. That's okay. But what I am gonna do to really consolidate your, your understanding of this is give you a question. It doesn't really have Avogadro's law per se, but it has all of the other elements of mole concept. And then we're just gonna work through that. I would love if I could have a volunteer though to work through it. And then we'll wrap up there for this week because we only have 15 minutes left. So let's do that. How does that sound to you, lovely students? Yes, no? Where are you with this stuff? Stop sharing this. Is that okay, guys? I'm seeing all of you know, so just let me know. Thumbs up. What do you want? Are you okay with doing one more question on more concept? And then just that will be a wrap up. Okay, I see those thumbs up. Hopefully the rest of you guys aren't sleeping, who aren't indicating anything. No thumbs up, no thumbs down. I need to see something. So I know that you are alive and you are with us and that you're paying attention. Okay. All right, I see those thumbs up going up. I see them. I know you guys are there. All right, so let me pull up this last question. And I need a volunteer. To do this question. Actually, let me see if I have a harder question than this. Let's see. Give me a minute, guys. Let me see if I have a hard one. We only have 15 minutes, so it can't be that hard. But I want to give you a hard one because I want to see that you are learning all the things. That not hard enough. Oh gosh, I'm just gonna give you the question I may have. And then maybe I'll make the quiz question a hard one. I'm gonna do that. I want to make the quiz question for this week that will go out tomorrow morning, a hard one. But for today, I'm just gonna give you guys this, which I think is fairly reasonable and fair for you guys, given what we've covered for the past 3 weeks, really. All right, so here we go. I need a volunteer, guys. All right, maybe I could do a giveaway here. If I have somebody work this out and get it right, I can do a giveaway. What could I give you though? Let's see. Maybe I'll do that. Maybe I'll give a giveaway if I have somebody to do this, because I need somebody to do this problem. God no, I need somebody to do this. Let me see. If you're interested in doing this for the chance of winning a free one-on-one tutorial session with me, where you can get all of your questions answered and one-on-one attention, let me know. Raise your hand and I'll let you do this question. How about that? Who is there? Who is on the line? Who is on the line? Who is going to do this question for the chance to win a free one-on-one session to get all your questions answered? And honestly, let me not say that. I want you to get it right, but if you don't get it right and I see that you're attempting and that you're trying and that you're thinking, I'll still give you the free session. But I need one of you guys to do it. Who will that be? Who will that lucky student be today who will do this question, attempt it at the very least, and to the best of their ability to win a one-on-one session with me? Who will it be? I have a lot of you here now, so there has to be somebody who is brave enough to take on this question. Who will it be? All right, going once. Going once. Going twice. Oh, wow, I don't see anybody saying anything, guys. You really fluffing me like this? And me alone so excited about more concept. Nobody now want to take it on? Me. Paige says me. All right. Nalani, were you interested in doing it? You said sounds good. I don't know what you're talking about. Paige says me. So I'm going to make Paige go ahead. Chanel just said she can try. Well, you come in after Paige. So Paige, can you use a text box and just kind of talk me through what you would be doing for this problem? And Aquila left us. So bye, Aquila. I know she said she had to go at 2 and I just realized that she left. So Aquila had to leave. Paige, come in first. Paige says me. Should she go and do it? Chanel says she can try. So let's see. maybe what I could do is if Paige gets stuck and Chanel can help her figure it out, I'll do is either I can do you guys together or I'll do one-on-one for each of you. How about that? How does that sound? Paige and Chanel. If Paige gets stuck and Chanel want to help her, I can allow that, and then I can give both of you free sessions. All right. Oh, okay. All right. You guys are talking to me, but you guys are telling me that sounds good, but I don't see any typing on the screen. Guys, come on. Take out the text box now and type. Type in your answer, type in your approach so we can all see, right? And then Chanel can tag team with you as needed, and I will compensate you guys accordingly. I will reward you guys accordingly for participating. And then of course I'll have a hard question tomorrow for a quiz question, and then whoever wins that will also get a chance to get a free session to get all their questions answered as well. So that's where we are. So okay, is Chanel and Paige, are any of you guys typing? I don't see any activity on my screen as yet. Are you guys typing? Oof. Oh no. Where did it go? There we are. All right, I'm not hearing anything from them. All right, see somebody just said something in the chat now. Jabari said, I'd like to try. All right, Jabari, write on my screen and go ahead, because I don't see Paige and Chanel writing a thing. They're not answering me to let me know if they're writing anything. So Jabari, if you can just pop on the screen and start writing ASAP, I will see what you have there for us, and then you'll be rewarded accordingly. I'm a woman of my word. I keep my word, and for your participation, you will be rewarded. Jabari, so Jabari goes so boom. Jabari start right same time. I love it. I love that, Jabari. I love that. All right, Paige dropped something in there. No, not when about Paige answer, but Paige dropped something there. Let me see what Paige do. Jabari is writing on the big screen, so all of us can see that. But Paige is talking in the chat, so Paige say 1 mole. 11.2 grams of potassium hydroxide, molar mass of potassium hydroxide. So that gives you your mole of potassium hydroxide. That's great. So you have that. Jamar is writing his answer, but Jamar, you have to tell me where you get the answer, Jamar. You have to show me your steps, right? So if it is that you're typing in the chat, Jamar, please type out your steps too, so I can see, because I can see everything, right? Jabari is writing on the big screen, so we can all see what Jabari is doing. But the people who are talking, communicating with me in the chat, don't just give me an answer. You have to give me your line by line. You don't have to write out what you're thinking word for word, but just show me the general steps that you're taking. See? So I can follow and I can see that your thinking is correct, or I can see where there are any gaps and I can help you to fill in those gaps, okay? So Jamar, definitely do that moving forward. Write your steps. And I see Paige, show me the first step now. Paige, or the rest, Paige, I want the rest of the answer from you. And let me write down the names of the people who are giving me this answer. Chanel, are you still there? I haven't seen anything from you. But you did
Yes, Miss, I'm typing it because I don't know how to write on the screen.
Okay, so you're typing it then. Very good. Lord, so I'm gonna be booked out all of this week, you know, because I have to give all of you guys sessions. Oh Lord, what did I get myself into? All right, so that's Paige. I'm writing down the names, you know. Paige, Chanel, Jamar is talking. Jabari is brave and bold enough to be writing on the main screen, and I love that. Did I miss you? If you're solving this problem right now, did I miss you? I have Paige, Chanel, Jamar, Jabari for session, so one-on-one session. So that's 4 people. Boom. Am I missing anyone? Let's see. Akeen is jumping. All right, Akeen. I hope I'm pronouncing your name right. Akeen is saying something now. Akeen, write out your work so I can see what you're thinking. What you're thinking is all right. So basically, guys, what is being done here is okay. You're given a mass, so you have a given mass of potassium hydroxide. So that's 11.2 grams of potassium hydroxide. So that's KOH, right? So we have to find the molar mass or KOH, and so that's the mass number of potassium is 39. Oxygen is 16 and hydrogen is 1. So that's 17 plus 39. And so that's 56, right? So that's your molar mass of potassium hydroxide. And you do mass divided by molar mass, and that gives you moles. So that's the first that everybody is getting. And everybody's getting that right. They're saying, oh, the molar mass is, let me see what people get. So Jamar says 0.036. Jamar says 0.036, and he showed me his answer. That's for 1. So the answer for part 1 is 0.036. Wait, why is it that I'm seeing so many different variations of this? I have to pull up my calculator.
0.2. I made a mistake, miss.
Okay, who made a mistake?
Miss Jamar, miss.
Okay, so that's okay. It's okay. It's the approach that counts, right? So let's see. So I'm calculating it now too, just to make sure we're all clear. So we're doing, guys, so just so we're on the same page, we're doing 11.2 grams divided by 56 grams per mole, and that's 0.2 moles, right? So the amount of moles of potassium hydroxide that Alyssa has is 0.2 moles, all right? So then the second part is saying how many moles of potassium sulfate would she be able to produce? That's this one right here, right? And you can see that the ratio is a 2-to-1 ratio, right? So if Alyssa has 0.2 moles of potassium hydroxide, then she'll be able to produce how many moles of potassium sulfate, right? Based on that ratio. So it's a 2-to-1, right? So Jamar is a 0.1, Deshan is a 0.1, Kaylee is a 0.1, Kaylee get all of them right too. Jamar is a 0.2, Milan is jumping in as well, it's a 0.2, but Milan's a 0.02, I'm not quite sure. Britannia says 0.2, bam, 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 bam. Does everybody get that? The point, does everybody get the 11.2 divided by 56 stuff? That's 0.2, right? And because it's a 2-to-1 and we have 0.2 KOH, that means we're gonna get half of that. So we're gonna get 0.1 moles of potassium sulfate. That's how many moles Alyssa will be able to produce because that's the proportion. And then the mass now is just the moles times the molar mass of potassium sulfate. What's the molar mass of potassium sulfate, guys? Okay, Milan, understood. So Daniel Day says moles is equal to the mass divided by molar mass. All right, so then to get your mass now, Daniel, how would you get that mass? Day Chanel, Claude, and Kalia says the molar mass of potassium sulfate is 174 grams per mole. All right, so then what's your final step, guys? Final step is then to multiply something by something, right? What are you multiplying now to get that mass of potassium sulfate that Alyssa could produce? All right, so Kalia says 0.1 moles times the molar mass. So that's 17.4 grams that Kalia gets. Jamar said the mole times the molar mass. That's exactly right. And Chanel said 0.1 times 174. All right. Great job, guys. Give yourself a round of applause. Yay. All right. You know where that clap and emoji is? Clap yourself. Clap yourselves. Clap yourselves. Clap yourself. Very well done. All right. So I think, sorry about that. Who was right? Somebody was writing on the screen. Sorry. So are we all clear on this, guys? Are we all good on this? I'm gonna stop sharing my screen and just chat to you guys for a little bit. I'm gonna come back where I can see all of you and I can see all the reactions and whatever is going on here. What time is it? 2:30. 2:30 on the dot. Guys, we did well. Give yourselves a round of applause. Let me see if I can clap too. Where are my emoji things? I'm gonna clap too. I'm gonna clap. See, I'm doing my clap and emoji. Yay, guys, we did well today. We did really well today. You guys did well today. You participated a lot, especially at the end, right? And so I owe Paige, Deschanel, Jamar, and Jabari one-on-one sessions, right? So you guys email me. I'm gonna put my email in the thing, in the chat, and you just email me with your availability. And then we'll set up a one-on-one meeting. So that's 4 people that I'm meeting one-on-one because of your bravery and your willingness to participate today. And so going forward, I'll definitely be doing this, a similar thing. And of course, we have the quiz on the page tomorrow on the Instagram page. And if anybody can get that question, I will come up with a hard question, a very hard question, and put that one on the Instagram page. And then whoever wins that will then have a chance to win. I know I have multiple answers, right? And whoever uses the hashtag and answers the question correctly will win a one-on-one session. So if you didn't win today, don't worry. Just keep your eyes peeled for the quiz, which will go out tomorrow. And then I'll give you until Tuesday to do it. On Tuesday, I'll post the answer on the same Instagram page. But you'll have a chance to win a one-on-one if you keep your eyes peeled there and give me the answer and use that hashtag that I just put in the chat. So my email is in the chat for Paige, Deschanel, Jamar, and Jabari. Email me your availability for a one-on-one session. It can be next week or the other week. Just email me and tell me your availability and I will work it out and see what my calendar is like and then send you a Zoom link for a meeting, right? And for that meeting, you come with your questions, your deepest, your most puzzling questions on mole concept or any topic for that matter, right? It's not just mole concept. You have a one-on-one session, make the most of it and ask me whatever you want, okay? You deserve it. You earned it today. So thank you for that. Thank you for participating, guys. And this is where we end for today. So thank you for coming and thank you for your undivided attention, guys. It means a lot to me, but I'm also always so encouraged and excited when I see, people taking ownership and taking charge of their own learning. And that's what you're doing by being here today on a Sunday. You could just be Netflixing and just chilling, right? You could be doing whatever it is that you wanted to do right now because you have free will, but you have chosen to come to this free CXC class online here. And that in and of itself speaks a lot about you and where you're trying to go and who you're trying to be. So I applaud you for that. So thanks for that. And follow us on Instagram if you're not yet following us on Instagram. So you'll be the first to know what's going on, what's the latest with us. And then of course we're going into week 4, which is our last week. We'll see if that changes, but it's our last week of free classes. So those of you who have been riding with me from the beginning, thank you for that. And I hope to see you next week as we wrap up this. Well, I guess we're going to start a new topic then, right? Oxidation and reduction. And then if you wanted to do the quiz and you came in late and so you're not seeing the link, I'm going to drop those links again. So you can do these quizzes to further assess your how you're grasping this. And just so you're clear on everything. Guys, like if you don't understand anything else in chemistry, well, let me not say that. If you understand more concept in chemistry, you can understand everything else. But if you don't understand anything else, if everything else goes over your head, mole concept is the one thing that I don't want to go over your head, because it's hard to come back from that, right? It's very hard to come back from that. So I just gave you, I hope these are two distinct links. Let me see if they're different. Yes, there are two different links I put in the chat. It's a quiz 1 and a quiz more concept. Quiz 1, that's like the fundamental basic stuff. And then quiz 2 has Avogadro's law and more complex stuff like balancing equation and all that stuff. So definitely do that quiz in your downtime this week. You have a little lunch break at school, instead of being on TikTok or any other random thing, just log in and do this quiz and make sure that your mole concept is crisp so that when CXE come, you're ready, okay? All right. So let's give the TikTok a little break and do this, okay? All right, guys. I said bye already. Let me tell you bye again. Have a great week. It was a pleasure being here with you. You know where to find me. I'm on Instagram. I'm on YouTube. I have my email. Just let me know, okay? Just be talking with me and let me know what's going on with you, from a chemistry standpoint, from a STEM standpoint, from a life standpoint, whatever it is. I'm here, okay? All right. So bye.
Miss.
What is
Miss
that?
Ethel,
Janelle?
don't forget to send the links to me, please.
What? Okay, yeah. Oh, you said something. I should send something to your WhatsApp. Let me see. Let me go back to see that real quick before I come out. Okay, let me write down your number. You said you wanted me to send the quiz on your WhatsApp, Janelle?
Yeah, miss.
Okay, so let me write down your number. Where are you? Are you in Jamaica or Trinidad?
TNT.
What's your area code?
1868.
Okay. All right, so I got your number and I'll send you the quiz there, okay, on WhatsApp.
Okay.
Okay, but you had a good time today? You learned a lot?
Yeah, miss.
All right, then have a great week now,
Miss, I had to
Janelle.
talk to you about the paper 3.
Okay, I'm gonna go back and check our chat, okay?
Miss, you did get a chance to look at it?
I'm not let me see, I don't think, let me double check on that and get back to you. When I message you the quiz, I'll take a quick look at it same time and let you know, okay?
Okay,
But I haven't been doing too much in the way of what am I saying? Of paper 3 stuff, lab stuff. I've just been focusing on the core syllabus so far. So, but I've been getting a lot of requests for help and so on as far as labs go and paper 3, because paper 3 is experimental stuff, right? So it's kind of a similar thing, but I haven't done too much in the way of that, but I'll definitely look a little bit more closely to it, given that there seems to be a need in that area, and I'll let you know, okay?
Okay.
All right, bye guys. Have a great week and definitely follow us on IG for more questions, okay? All right.